Hi, this is Alex from devstories.eu. LiteLLM, the Universal LLM Gateway, Episode 13 of 24. Why pay an external API to generate the exact same basic explanation 1,000 times? You burn credits and force users to wait for computations that have already been done. Resolving this inefficiency is the core of caching for speed and savings. LiteLLM handles caching entirely at the proxy level. When a request comes in, the proxy checks if it has seen this exact prompt before. If it has, it returns the stored response immediately. Latency drops from seconds to milliseconds, and the API cost drops to 0. To set this up, you use your config.yaml file. You enable caching in your global settings block by setting cache to true and specify your cache type. Redis is the standard backend for exact match caching. You provide your Redis host, port, and password, and the proxy takes care of storing the input-output pairs. But exact caching is brittle. It looks for a perfect string match. If one user asks, write a poem about LiteLLM, and another user asks, create a LiteLLM poem, an exact cache sees two completely different requests. It forwards the second request to the heavy language model, wasting time and money on a redundant task just because the phrasing changed slightly. This is where semantic caching comes in. Instead of comparing raw text strings, semantic caching compares the underlying meaning of the prompts. LiteLLM supports Qdrant, a vector database, to handle this. When you configure semantic caching, you must specify an embedding model alongside your main generation model. When a request arrives, the proxy passes the prompt to the embedding model first. This model converts the text into a vector, which is a mathematical representation of the prompt's meaning. The proxy then queries Qdrant to see if a similar vector already exists in the cache. Because write a poem and create a poem share the same semantic intent, their vectors map closely together in space. Qdrant detects the similarity. If the match is close enough, the proxy pulls the cached response from the first user and delivers it to the second user. You skip the heavy text generation step entirely, paying only a fraction of a cent for the fast embedding lookup. Configuring this requires a few more lines in your config.yaml file. You change the cache type to Qdrant semantic, you define Qdrant-specific parameters like the Qdrant endpoint URL and your API key. Most importantly, you define a similarity threshold. This is a decimal value between 0 and 1. A high threshold like 0.99 demands near-identical phrasing. A lower threshold like 0.8 catches broader variations, but increases the risk of returning an outdated or slightly off-topic answer if two prompts sound similar but have different intents. Here is the key insight. Semantic caching is not just a storage mechanism, it is an active filter for user intent. Tuning your similarity threshold is the only thing standing between a massive cost reduction and returning irrelevant answers to your users. Thanks for listening. Happy coding, everyone.